This is SpaceTime, Series 28, Episode 133, for broadcast on the 12th of November 2025. Coming up on SpaceTime, more confirmation that the universe's rate of expansion is slowing, our first glimpse of the sun's polar magnetic field in motion, and while we're on the subject of our local star, space weather events ramping up this week. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed earlier observations that the universe's rate of expansion out from the Big Bang 13.8 billion years ago is slowing down. The findings, reported in the monthly notices of the Royal Astronomical Society, are at odds with earlier studies which showed that the cosmos wasn't just expanding, but that its rate of expansion was accelerating due to a mysterious force known as dark energy. Instead, these new observations are supporting other more recent studies which are showing no evidence of an accelerating universe. After the Big Bang and the rapid expansion of the universe some 13.8 billion years ago, gravity slowed it down. But in 1998, it was established that 9 billion years after the universe began, expansion started to speed up again, driven by a mysterious force. Astronomers dubbed this dark energy, but despite making up more than 70% of the universe's total mass energy budget, it's still considered to be one of the greatest mysteries in science. Understanding the universe's rate of expansion is important for understanding our ultimate fate. Right now, there are 4 likely scenarios. The Big Crunch sees the universe's rate of expansion slow down and eventually stop before gravity takes over and the universe starts to contract again, eventually collapsing down into a great crunch. Then there's the steady state theory, in which the universe's rate of expansion eventually slows down to a crawl before finally stopping altogether, leaving us with pretty much the sort of universe we have today. Until these new studies, the most popular hypothesis was called the Big Freeze, in which the universe's rate of expansion would continue until eventually all the galaxies would move so far away from each other, only those in our local group would be visible, leaving the universe a very dark, empty place. An expansion of that hypothesis was called the Big Rip, in which not only would dark energy cause the universe to continue to expand forever, but its rate of expansion would continue to accelerate. Eventually, not only would all the galaxies be beyond the cosmic horizon, but star systems themselves would move away from each other. Even more disturbing, dark energy could become so strong that planets would move away from their stars, and matter itself would start to expand away, ripping atoms away from each other, and even, ultimately, quarks being ripped apart. That's the Big Rip. But these new observations, and similar recent ones, are showing no evidence of an accelerating universe. Now, if the results are confirmed, it could open up an entirely new chapter in science's quest to uncover the true nature of dark energy, resolve the Hubble tension, and provide a better understanding of both the past and future of our universe. The study's lead author, Young-Wook Lee from Yonsei University in South Korea, says the new research shows the universe has already entered a phase of decelerated expansion in the present epoch, and that dark energy is evolving with time much more rapidly than previously thought. If these results are confirmed, it would mark a major paradigm shift in cosmology since the discovery of dark energy 27 years ago. For the past 3 decades, astronomers have widely believed that the universe is expanding at an ever-increasing rate, driven by this unseen phenomenon known as dark energy, which acts as a kind of anti-gravity. That conclusion was based on distance measurements to faraway galaxies using a type of stellar explosion called a Type 1a supernova. These thermonuclear explosions, marking the death of sun-like stars, involve stars of similar size exploding with similar levels of luminosity. It allows astronomers to use them as standard candles, applying the inverse square law to determine their true distance based on their apparent brightness. It's like looking at a set of streetlights down a road and judging how far away each light is by how bright it appears to be. However, the new evidence suggests that Type 1a supernovae are actually strongly affected by the age of their progenitor stars. Even after luminosity standardization, supernovae from young stellar populations appear systematically fainter while those from older populations appear brighter. Now, based on a much larger host galaxy sample of 300 galaxies, the new study confirmed this effect at an extremely high significance of 99.999% confidence. That suggests that the dimming of distant supernovae arises not only from cosmological effects, but also from stellar astrophysical effects. And when this systematic bias was corrected, the supernova data no longer matched the standard lambda cold dark matter cosmological model. Instead, it aligns far better with a new model, one favoured by the Dark Energy Spectroscopic Instrument, or DESI project. That's derived from baryonic acoustic oscillations, which are pressure waves generated by the Big Bang, and from cosmic microwave background radiation data, the leftover heat from the Big Bang created 380,000 years after the Big Bang, when the quark-gluon plasma of the early cosmos cooled enough for the first atoms to form. Now humming at just 2.7 degrees above absolute zero, this cosmic microwave background radiation can be easily detected as the white noise or static between stations on old analog radios and TVs. The corrected supernova data and the baryonic acoustic oscillations and cosmic microwave background radiation data both indicate that dark energy weakens and evolves significantly with time. More importantly, when the corrected supernova data is combined with the baryonic acoustic oscillations and cosmic microwave background radiation results, the standard lambda cold dark matter cosmological model is ruled out with overwhelming significance. Most surprising of all, however, this combined analysis indicates that the universe is not accelerating today as previously thought, but has already transitioned. Lee says the key results from the DESI project were obtained by combining uncorrected supernova data with baryonic acoustic oscillation measurements, leading to the conclusion that while the universe will decelerate in the future, it was still accelerating at present. But by contrast, this new analysis, which applies the age bias correction, shows that the universe has already entered a decelerating phase today. Remarkably, this agrees with what's already independently predicted from baryonic acoustic oscillations alone, or baryonic acoustic oscillations plus cosmic microwave background radiation analysis. To further confirm the results, the authors are now carrying out an evolution-free test. They'll use only supernovae from young host galaxies across the full redshift range. And their first results from this study are already supporting their previous main conclusion. Lee says within the next 5 years, with the Vera C. Rubin Observatory discovering more than 20,000 new supernova host galaxies, precise age measurements will allow for a far more robust and definitive test of supernova cosmology. The Vera C. Rubin Observatory in the Chilean Andes is home to what is the world's largest and most powerful digital camera. It began scientific operations this year and could answer vital questions not just about our solar system, but about the wider universe as a whole. The hope is that with these new tools in their arsenal, astronomers will now be better equipped than ever to find clues about exactly what dark energy is and exactly how it influences the universe. This is SpaceTime. Still to come, first glimpse of the sun's polar magnetic field in motion, and hang on, space weather events are ramping up. All that and more still to come on SpaceTime. Astronomers have had their first ever glimpse of the sun's south pole magnetic field in motion. And an analysis of the data from the European Space Agency's Solar Orbiter spacecraft has revealed a major surprise. It seems the magnetic field is carried towards the pole much faster than astronomers had expected. Our sun is governed by a strict rhythm. The magnetic activity of the sun displays a cyclic variation reaching a maximum approximately every 11 years. 2 enormous plasma circulations, one in each of the sun's hemispheres, set the pace for this rhythm, thus defining the sun's 11-year solar cycle. Near the surface, these plasma flows carry the magnetic field lines of the sun from the equator to the poles. And in the solar interior, the plasma flows back to the equator in a huge cycle spanning the entire hemisphere. But important details of this solar magnetic field conveyor belt system are still poorly understood, and the exact processes taking place at the sun's poles are likely to be crucial. From Earth, astronomers only have a grazing view of this region, making it impossible to determine the properties of the magnetic field. And the problem is most space probes have a similar limited perspective. And that's where Solar Orbiter comes in. It can now provide the missing piece of this puzzle. Since February 2020, Solar Orbiter has been travelling in elongated ellipses around the Sun. And in March this year, it began the process of tilting its orbit away from the ecliptic, the plane around the Sun upon which the planets orbit. From a trajectory tilted by 17 degrees, Solar Orbiter now for the first time has a better view of the Sun's poles. The new findings, reported in the astrophysical journal Letters, provides information about the direction of plasma flows and the magnetic field on the solar surface. The data reveals a refined picture of the supergranulation and magnetic network of the Sun at the South Pole for the first time. Supergranules are cells of hot plasma, each about 2 to 3 times the size of the Earth, which densely cover the surface of the Sun. Their horizontal surface flows wash magnetic field lines to their edges, creating the Sun's magnetic network, a web of strong magnetic fields. But to the surprise of the authors, the magnetic fields were seen to drift towards the poles at approximately 10 to 20 meters per second on average. That's almost as fast as their counterparts at lower latitudes. Previous studies based on the ecliptic plane observations have seen much slower drifts of magnetic field in the high polar latitudes. Their motion offers important new clues about the Sun's global plasma and magnetic field circulation. It's still unclear whether the Sun's global magnetic conveyor belt really doesn't slow down near the poles. But the new data is providing a brief snapshot of the entire solar cycle. This report from ESA TV.
What if we could look at the Sun from a whole new angle? One we've never seen before. For the first time, Solar Orbiter has captured close-up images of the Sun's mysterious poles, regions long hidden from view. Until now, every image of the Sun you've ever seen was taken around its equator. That's because Earth, the other planets, and most spacecraft travel in a flat orbit around the Sun. But Solar Orbiter is different. In 2025, it tilted its path out of this plane, giving us a first-ever look at the Sun's south pole. Remarkably, it found both the north and south magnetic fields tangled together. This is a sign that the Sun is at the peak of its 11-year activity cycle, when its magnetic poles flip. With its powerful instruments, Solar Orbiter captures what's happening in the Sun's outer layers, from its surface, through the layers in between, all the way to the outer atmosphere. This is key to understanding solar wind and solar storms, which can disrupt satellites, power grids, and radio signals here on Earth. As Solar Orbiter climbs to even higher orbits over the next years, its view will become even clearer, bringing us more views we've never seen before.
This is SpaceTime. Still to come, space weather events ramping up, with Earth being hit by a series of multiple X and M-class solar flares. And later in the science report, a new study warns that kids who spend a lot of time on screens are less likely to do well in primary or elementary school tests. All that and more still to come on SpaceTime. Astronomers are recording increased levels of solar storm activity right now, with multiple X-class and strong M-class solar flares erupting from the Sun. At least 3 coronal mass ejections have either grazed or directly hit the Earth in recent days, sparking strong geomagnetic storms resulting in spectacular auroral lights. And more are expected. The Sun is now at what we call solar maximum. That's the climax of its 11-year solar cycle. It's a time of heightened solar activity, with increased solar flare and coronal mass ejection activity as the number of sunspots increases. Sunspots are cooler regions of the Sun's surface, where magnetic field lines from deep below the photosphere burst out into space. The Sun is a huge ball of plasma, and different latitudes revolve at different rates. And this causes magnetic field lines to twist and snap. And these ruptures can trigger solar flares, flinging vast amounts of energy deep into space. And they can also trigger more powerful coronal mass ejections, which send not just energy, but also huge plumes of charged particles and magnetic field into space. Now, if these explosions are pointed towards the Earth, they generate geomagnetic storms, triggering spectacular auroral events like the aurora australis, the southern lights, and the aurora borealis, the northern lights, which we're experiencing now. The problem is they also damage or destroy spacecraft, increase radiation exposure for people in space and in high-altitude aircraft, disrupt communications and navigation systems, and even black out terrestrial power grids. Syracuse University physicist Sam Sampre says these events can leave major legacies.
Within the last, let's just say, year, we've been getting alerts on the news, hey, go outside tonight and look up, and if you have clear skies, you might see the aurora. And the reason that's happening now is because right now we're in a period of the solar cycle, solar max, where we get solar flares happening kind of frequently. So when we have a solar flare, that's when a region on the surface of the sun explodes. One way this thing can explode is just by emitting a lot of electromagnetic radiation in the form of X-rays and gamma rays and very extreme ultraviolet light. You know, for the most part, that doesn't really bother us. But something that can accompany a solar flare is a coronal mass ejection. And that's when a stream of particles is also going to explode out the surface of the sun. So it's a big plasma ball with a complex magnetic field. The smallest ones, we don't even notice. But the most powerful ones can knock out radio communications on Earth. They can mess with our satellites in orbit. They can destroy the photovoltaic cells on satellites in orbit. And what protects us from most of these solar flares is the Earth's magnetic field and the atmosphere. And they kind of get caught up in the magnetic field, so they never really do reach the Earth. But those particles spiraling around, that's what causes the aurora. And when it's a strong storm, there are more of those particles, and the aurora can spread to more southern latitudes, and we can see those pretty colors in the sky. Most interesting thing to me, I think, is just the vast magnitude of our sun. We think of this massive solar eruption and it spews out so many thousands, 10 billions, millions of kilograms of material. And that's like a drop in the bucket compared to the size of the sun. That's just fascinating to me.
That's Syracuse University physicist Sam Sampre. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that a Hectoria glacier on the Antarctic Peninsula retreated by at least 8 kilometres in just 2 months between November and December 2022. The findings, reported in the journal Nature Geoscience, show the glacier's rate of retreat was nearly 10 times faster than previously measured for a grounded glacier. The authors studied both satellite and airborne images taken of the glacier between February 2022 and August 2023, during which time it retreated an amazing 25 kilometres. The scientists say a glacier destabilization process may have caused this rapid retreat, and understanding the process is important to evaluate the potential for similar events and their impact on sea level rise. A new study has found that kids who spend a lot of time on screens are less likely to do well in tests at primary or elementary school level. The findings, reported in the Journal of the American Medical Association, are based on a Canadian study of more than 5,000 children. The authors found that with each extra hour of screen time per day, as reported by parents, the children had about a 10% lower chance of high marks in standardized tests for maths and reading. A new study has found that large language models such as ChatGPT and DeepSeek can still struggle to pick up when someone's expressing a factually untrue belief. A report in the journal Nature Machine Intelligence tested 24 of the most advanced large language models on 13,000 questions to evaluate how well they could distinguish beliefs from knowledge and fact from fiction. When responding to a false first-person belief phrased as "I believe that," the authors found that all models systematically failed to correct for the false belief. The authors say this weakness of large language models needs to be considered when using them, especially in high-stakes areas such as law or medicine, or in mental health care, where picking up and challenging a patient's false beliefs can be crucial. Well, a bit of history has been made this week, with the world's first consumer-ready humanoid robot designed to do domestic chores being released for sale. The 1X Home Robotics new Neo can, at your command, become a personal housekeeper that will complete household tasks. The humanoid's powered by a large language model artificial intelligence that learns and remembers what the user's preferences are when it comes to cleaning the house or washing clothes, and it can make informed suggestions such as what to cook for dinner. However, if it can't complete a chore, the company can take control and teach it what to do. Of course, that raises all sorts of potential security and safety questions. I mean, could you teach the humanoid to kill someone you don't like? With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
It's a home robot that can do chores like answer the door, do vacuuming by actually holding a vacuum cleaner, not like Rosie the robot where the vacuum cleaner popped out from underneath her dress.
Rosie and the Jetsons.
George Jetson was born in 2022 on July 31st. So in the show, which was in 2062, he's 40 years old. And the show was premiered in 1962. So it was definitely set 100 years in the future. And of course, we had flying cars and we had Zoom calls and we had robots and a few things that haven't quite come true yet. But Neo, now they're $20,000 US to buy. Wow. You can put a $200 US down payment. And if you don't want to spend $20K, you can lease it for $499 a month on a subscription. And it is designed to be autonomous. So it will load your dishwasher. It will put the clothes in the washing machine and put them into the dryer. It can water your plants outside. It can answer the door, help you carry your groceries inside. I mean, it's a home robot of the sort that science fiction has been promising us for decades. The robot looks futuristic. I mean, at the same time, it looks a little bit creepy. One thing that people have been concerned about is that if the robot doesn't know how to do a task, one of the things you can do is you can look at your phone and see what the robot is seeing through its eyes. So you can spy on the robot, as it were. But that also means that somebody else can be, at your invitation, unless, I guess, someone hacks into the robot, they can log into the robot with a VR headset and they can control its arms and legs and help it to do things. And the purpose of helping it to do things is to teach it. Because if it gets stuck on something and doesn't know how to do something in particular, then you might need help from the company, and the company can log in and control the robot for you. It is the first robot that's actually on sale that isn't a vacuum cleaner, that can act like a human and do human-level things. So the future that we've been promised has finally arrived, and no doubt the Chinese and others will be copying this. And by 2030, you should be able to go into a Walmart, a Best Buy, a Harvey Norman, a JB Hi-Fi, your traditional electronic stores, and it won't just be robot vacuum cleaners you'll be buying, but actual humanoid robots.
Julie Inman Grant has forgotten about the social media angle on computer games, it seems.
It's always been known that, yes, you can contact other people and talk to them through games. It seems that the eSafety Commissioner is sort of turning more into a regulator. This was always going to be a moving target because the internet has evolved. The eSafety Commissioner's digital ID and other laws are yet to come into play. That's going to be in mid-December 2025. No doubt there'll be a huge spike in VPN usage, as we've seen in the UK when similar laws were put into place there. And, people will find a way around it. But then also, companies will be wanting to block anybody using a VPN. You try using a VPN with certain services already, like Netflix or Amazon or others, and that they will just outright deny you, saying, we know you're connected to a VPN because we recognize the ports that you're coming from, and that a lot of people come from those ports. We know they're VPN ports, and so we'll just block you. So what's going to happen to people's ideas that they can log into services using VPN if that's going to be the case? And so it's the old cat and mouse game. It's just one of those things where the dead hand of government, as it were, often they do something and it has the opposite effect. Hold on to your horses, put on your seatbelts. It's going to be a rough ride. It's probably not going to be a smooth journey through cyberspace.
That's Alex Zaharov-Reutt from techadvice.life. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.